would like to start our program. We have a speaker all the way from Brazil. I think it is 2 a.m. in Brazil. I would like to invite Professor Normando Perazzo Barbosa. He is a civil engineer in the University of Pernambuco, Brazil. He has worked in many areas in the field of bamboo and 150 publications besides book chapters, coordinators of laboratory works, testing materials structures where research and consulting works are done. He was responsible for many programs of replacement of more than 30 sub-habitations in sandy towns using compressed earth blocks and adobes. It renders voluntary service to the community. His work has already been shown in network in Brazil TV and many other channels. So I would like to invite Professor Normando. Professor Normando, if you can please join.
Yes, but I needed you finish.
Yeah, we finished. Please, Dr. Normando.
Let's see if it works. You have to invite me.
Yeah.
No,
Can you just arrange his? Can you arrange him to share his video?
It says that I can share.
Please, we'll just work it out. Kevin, can you please help him?
If you needed to make, I became a presenter.
Yeah. Jack, can you just help him out?
Okay.
Yeah.
Okay.
Okay. Okay. Thank you, Normando. Please start. Yeah.
It's okay.
Isso, por aí.
Good morning, good afternoon, everybody around the world. Firstly, I would like to thank Mr. Kamesh Salam the invitation to participate of this interesting event. I will talk something about bamboo in Brazil and something about the standards we have. I work for the Federal University of Paraíba. People living here, and then we have a lot of beautiful and pleasant beaches. Well, talking about bamboo in the 21st century, with so much technological development, one reason, Earth is a finite planet. Another reason, industrialized materials has as characteristic high energy consumption. If we see the temperatures needed to fabricate them, we can see that these industrialized materials have incorporated a lot of energy. In a finite planet, energy has been the cause of international conflicts created by the dominant countries that need to ensure their futures based on energy. One more reason is that the world population is arriving at 80 billion of people. Besides food, all these people need home, infrastructure, energy, etc. But the earth is finite. And the current way of life is the actual capitalism, very cruel. It requires a lot of the earth. It's a system based on consumption, on infinite growth. This system needed for large scale production, and it goes against a common sense on a finite planet. This capitalism has no brakes, no limits, and the accumulation of goods is part of this. Extreme inequalities necessarily arrive on a finite planet. But what does bamboo have to do with this? While industrialized materials consume a lot of energy, bamboo consumes solar energy. While industrialized materials consume non-renewable raw materials, bamboo is a renewable materials. While industrialized materials degrade the environment, bamboo restores degraded areas. While industrialized materials release a lot of CO2 and other contaminants in the atmosphere, bamboo absorbs CO2. While industrialized materials generate waste that damage the environment, bamboo is biodegradable. Its residues can be reincorporated easily in the nature, even be reused. While industrialized material require a complex installation to be produced, sophisticated technology, bamboo is easily produced by nature. While wood takes a long time to grow and be used, bamboo grows quickly and plantations has continuous use. While industrialized material have good mechanical properties, also bamboo has good properties. Bamboo can replace a lot of products. Bamboo can replace plastic. As we can see, we know that there are more than 5,000 products made with bamboo. And in South America, there are a very large quantity of bamboo between Brazil and Peru in the middle of Amazon forest. More than 4 million of hectares in this area. In Brazil and other Latin American countries, the destruction of original forests are increasing. We intend to introduce bamboo as the main great contribution to the knowledge in Latin America and all the world was the architect, Colombian architect Oscar Hidalgo. His last book was Bamboo, the gift of the goods of the gods. In Brazil, we started the first systematic in Brazil, there are autóctones and exotic bamboo species. Great diversity, bamboo from a few centimeters and more than 30 meters. Exotics are the most used in architecture. Then Peru in 2012, Ecuador 2017, Brazil 2020. In Colombia, standard deals with police considering only guadua species. All this, as this standard refers only to guadua, it already indicates the allow in the material. We have here in deflection, traction, compression parallel, compression perpendicular, and shear. Over this stress, a series of attenuations load, etc. For me, an exaggeration, the number of coefficients. Concerning always guadua. And guadua angustifolia. Peruvian standard, in addition to the structure, presents a model of one this kind of there are a lot of information about bamboo walls, as you can see this type of wall. In the Equatorian standard, in addition to bamboo polish structure, also deals with bamboo wood panels. So there are many that details given about the panels. And bamboo wood panels a big standard they have in Ecuador. In Brazil, we have three standards. Of partial coefficients and limit states. So the characteristic strengths are obtained by mechanical tests, and the compression strength, as the compression strength is the easiest to obtain, the standard related the other mechanical properties to it. So tensile characteristical tensile strength, we can say it's 1.1.3 compression strength, characteristic compression strength parallel to fibers. and shear in compression perpendicular, flexion, and ion modulus. Design stress, it modifies the characteristic of stress by two coefficients. This related to materials, it depends on the solicitation, and this other is to consider the type of load, humidity, quality of the poles. This one is for beams. To control quality, 13 species must be taken from at least 6 different cumulus per batch of a maximum of 250 stems. The Brazilian standard presents also the formulation to calculate columns, beams, etc. In the annex, there is information on connection between structural elements. In some connection, it's recommended to fill the internodes with mortar, as you can see here. Concerning determination of physical and mechanical property, it's similar to the other Latin American standards and ISO standard. We just made some small simplifications. The third standard, bamboo poles for structural use, harvesting, immunizing treatment, classification by diameter. It gives some information about how to select the comb, how to dry, how to treat, how to transport. The intention of this standard is for bamboo to be used, and the consumer is assured that the material was harvested at the proper age, treated and dried properly. Insect treatment is mandatory. Here, this is called Asian tiger. Insects completely destroy the bamboo and the bamboo structures. To protect the extremity of the comb, a good idea is to use a PET bottle and hot air. This protect the bamboo. Grading by diameter, we want to bamboo poles can be commercialized with lengths of 3 meter and 6 meter. So it's interesting to fix that the difference between the biggest diameter and the maximum diameter and minimum diameter is limited to uh, uh, to guarantee that the conicity of the bamboo is in accordance with the standard of design of bamboo structures. And also, the curving of bamboo is limited as this value. Some bamboo construction in Brazil, the biggest one is in the Cultural Center Max Fever in São Paulo, Recreation Center in Amazonia, Bio Bamboo is an ecological school where bamboo building is taught. Celina Llarena is the director, which has built a lot of interesting construction using bamboo. We can see here several construction from Celina. for using bamboo. What the market here in Brazil? So here is a gym at the Catholic University of Rio de Janeiro, made by this group. And interesting, they use only this. This is not a temporary construction, not a temporary construction, but they use this type of connection. This type of connection. This was made at the university, bus stop in bamboo. Some in Brazil of heat treatment. We have here behavior under heat treatment of bamboo. We can see even temperature close to 150 degrees. Bamboo stick retain their properties. At the beginning, in the years 18, we started to study bamboo, and the idea was to reinforce concrete beams. But we have a lot of tests, but the performance is not very good due to the low models of elasticity of bamboo, which can be half of the concrete. And we study also bond strength, bamboo concrete, the durability of bamboo as concrete reinforcement, and concrete beams wall with bamboo. The maximum load is significant, but showed an almost brittle break. It's not interesting to use concrete bamboo as reinforced material. Small gypsum beam reinforced with bamboo. This prototype, we used here this kind of small beams. And since 2008, went out pathologies. Interesting way to use bamboo is a permanent bamboo formwork, for example. In steel, we have special connectors. In bamboo, we have natural connectors. So we can use half of the cum and concrete, and we have a good floor. It performs very well, but it is very flexible. But for normal loads, it works well. Bamboo also was studied. Development of connecting elements and the metallic elements for connections. The idea to use big blocks using microconcretes and cement, sand, this kind of microconcrete. Pieces of bamboo are placed in the formwork. The microconcrete completes the block. And there is an easy and fast construction you can do with using this. The first prototype from 2004. We started to study long panels. Use this high load battery capacity is incredible. To 20 tons here in the top of this is impact test of the body impact. As you can see, the test of the high maximum load capacity, 37 tons by meters. Bending test, thermal test, and bamboo macrostructure. Everybody knows that we that are the vessels here. You are studying the impregnation of the vessel with polymeric resins to put here some product. It works for the impregnation with resin is not easy. It's very difficult. We arrived to impregnate small pieces until now. Small pieces. We need to improve the method to have long pieces of bamboo impregnated. But it works very well against insects. Well, the future of bamboo in Brazil is promising. We have a Rede Brasileira do Bambu, national network of research and technological development integrated by researchers, technicians, and professionals of universities and research institutes. It's necessary to have material available. Production of seeding and plantations is necessary. As Brazil is very large, plantations are needed in all the regions to avoid long distance transport. There are currently numerous WhatsApp groups, bamboo groups in Brazil. And we repeat, the future of bamboo in Brazil is promising. Of course, there is still a lot to do to spread it. We hope it will change the reality of many people in the country, including those who need land and don't have it. For example, these are cases of extreme poverty from people landless. They live inside the bamboo plantations and do not know how to use and exploit this material. The intention is to organize a course of the use of bamboo, and hence bamboo can also contribute to improving living conditions in many people in Brazil. Thanks very much for your attention.
Thank you so much, Normando. It has been a wonderful presentation, and I look forward for more collaboration with Brazil, especially in construction. Your expertise are wonderful, and thank you so much again to speaking at the
Thanks a
midnight
lot.
in Brazil. Thank you so much. Thank you.